Hello Titans, hope your day is going great. We're going to finish up section 13.3 here, which is trig functions of any angle. Again, our goals are to find the trig functions of any angle, and we're going to do that today without using a calculator. And two, hopefully we got this all finished, find the reference angle of different angles greater than 90. Okay, now one of the questions I wanted to end class with yesterday was thinking about what connection can you make with the 6 trig functions you find and the reference angle of angles greater than 90 degrees. Well, what I was thinking here was when we graph these, and let's say my angle looks something like this, initial side, terminal side, and I had this point out here which was, let's just say -3, 4. Okay, and we wanted to find like the sine of theta, the cosine of theta, blah blah blah, tangent, the rest of those. Well, we said the sine was y over r and the cosine was x over r. Well, looking at this again, if I actually draw in a triangle here, okay, this height on the left side would be my y, or my 4. This bottom part would be the -3, and then the r that I don't have would be, it's a 3, 4, 5 triangle. So basing there, if the sine of theta is y over r, it's 4 over 5. The cosine of theta is x over r, which is -3 over 5. Well, when I think about that, basically what I just did was I have this triangle right here, and if I draw in this angle right here, which we learned yesterday was the reference angle, compared to that, 4 is the opposite side, -3 would be the adjacent side, and 5 would be the hypotenuse. And we know sine is opposite over hypotenuse, so opposite would be 4, hypotenuse would be 5, 4 over 5, which is what I found there. So hopefully we kind of recognize that this connection made here is I can draw a triangle with the reference angle and find the sine, cosine, or tangent and be able to solve for them. Because we learned yesterday that the reference angle and the original angle have the same sine, cosine, and tangent. So we draw that right triangle in that we are able to create. There's a little bit of a connection between those two things we did yesterday, and now we're going to put it all together today and use it to find trig functions of any angle without using a calculator. So let's go ahead and jump into this here. Say I want to evaluate the tangent of -210. Well, I'm going to take my calculator, I'm going to go -210 tangent. Boom. No, not today. What we want to do here is we want to draw it in first. So let's go ahead and draw it in. My initial side, -210, I'm going to go down, -90, -180, -210, draw in my angle. So my big angle is -210. If I want to find the reference angle though, I want to find this angle right here. So to find my reference angle, I go ahead and take -210 minus the x-axis, which is a -180, so really I'm adding it here. So I get theta primed equals -30. And again, we're always talking about positives, so I'm going to think it's a +30. So my reference angle here is 30 degrees. Well, that's great. Well, I just showed on the last slide that the reference angle has the same trig functions as the normal angle. But what does that have to do with what we're doing now? Well, the 30 degree, let me think back. Oh, I had a special triangle that was a 30, 60, 90 triangle. And a 30, 60, 90 triangle had sides 1, the square root of 2, and 2. Well, if I want to find the tangent of -210, I know that that's going to be the same as the tangent of -30, or 30. And based on my triangle right here, I use 30. 1 is the opposite. Square root of 2 is the adjacent. 2 is the hypotenuse. So if I want to find the tangent of negative 30, tangent is opposite over adjacent, so it's 1 over the square root of 2. So I just figured out what the tangent of negative 210 was. It's 1 over the square root of 2. Now technically we can't have the square root of 2 in the bottom of a fraction, so I need to get rid of that. How do I get rid of that? Multiplying the top and bottom by the square root of 2. That leaves me with the tangent of negative 30, or 30, is the square root of 2 over 2. Look at that right there. Pretty awesome. Just figured out that the tangent of negative 210 is the same as the tangent of 30, which is the square root of 2 over 2. And actually, it's going to be negative. So negative square root of 2 over 2. So I drew in my regular angle, found my reference angle, used my reference angle with this special triangle I had from earlier, and went ahead, found the tangent on it. And then we know that the tangent of the reference angle is the same as the tangent of the big angle. Look at that. Pretty awesome. Didn't even need a calculator. Calculator, if you typed it in right now, tangent of negative 210, you're going to get some decimal answer. We're not looking for decimal answers here. We're looking for real answers. Square root of 2 over 2 is a exact answer. Okay? So how did I know that that was negative? Well, here's kind of the signs of function values. In quadrant 1, I've got sine, cosine, and tangent. They're all going to be positive. In quadrant 2, the sine's just going to be positive. In quadrant 3, the tangent's just going to be positive. And in quadrant 4, the cosine's just going to be positive. The rest are all negative. So this is very, very important. If we got to pause right here to get this written down or anything, go ahead, pause so we get that written down. The signs of function values based on what quadrant they're in, right there. Okay, hopefully we paused. Now we're back at it. And you know, how am I supposed to remember that if I don't have my notes? Well, we came up with a little shortcut, and it's just a phrase we remember, and it's called all students take classes. All students take classes. Now, what the heck does that mean? All students take classes. Well, the A stands for quadrant 1. All, or A, all of them are positive. The students stands for quadrant 2, the S. Look at it in there. The sign is positive. That's the only one. All students take, so the T goes for quadrant 3. Look at that. The only one that's positive is the tangent. All students take classes. It used to be calculus, but now not everybody takes calculus, so we just say all students take classes. The C stands for quadrant 4. Look at that. The cosine's the only one that's positive. So you can tell which ones are positive, which ones are negative, based on all students take classes. It's just a little shortcut, so you don't have to memorize all of this right here. You can just memorize all students take classes. Okay? A little shortcut there. All right. Let's do another example. Let's do another couple examples, actually, after we realize what these special triangles are. Notice I used that special triangle in the first one, so this is coming from a couple sections ago, sorry. Make sure you write these down if you don't already have them. A 45, 45, 90 triangle has two 45-degree angles. The legs are 1 and 1, and the square root of 2 is the hypotenuse. Also make sure you've got the 30, 60, 90 triangle written down. The side opposite of 30 is 1, opposite of 60 is the square root of 3, and the hypotenuse is 2. So make sure you got these written down as well. All the ones we're going to ask you to find without a calculator are going to reference one of these two triangles. All right, hopefully we got those written down. Now let's do some more examples. I want to evaluate the sine of 240. All right, sine of 240. First thing I want to do is find the reference angle. So let's go ahead, graph 240, 90, 180. Not going to go to 270, so there is 240 degrees. And now I want to look. Where is my reference angle going to be? It's going to be right here. How do I find my reference angle? I got to take the 180, so 240 minus 180, the x-axis. I better reprose this by now. And we get 60 degrees. That 60 degrees tells me I'm going to use my 30, 60, 90 triangle. Side opposite of 30 is 1. Opposite of 60 is the square root of 2. And the hypotenuse is 2. So I'm looking for the sine, so I've got to compare everything to that 60. Well, this one's the opposite, this one's the hypotenuse, this one is adjacent. So the sine is opposite over adjacent, so the sine of 60 equals square root of 2, opposite over hypotenuse, over 2. So the sine of 240 equals the square root of 2 over 2. Now I just need to figure out, is it positive or negative? Well, all students take. I'm not looking for the tangent, I'm looking for the sine. So the sine is negative. So the sine of 240 is negative square root of 2 over 2. I used my special triangle, drew it, found the sine of that reference angle, and then that's the same as the sine of mine. Then used all students take calculus. Okay? Let's do another one here. Find the cosine of 11 pi over 4. Ooh, 11 pi over 4. Well, it'd be a good idea for me to graph that. I'm going to take 11 divided by 4, and I get 2.75 pi. Now, I can graph that a little easier. So 2.75 pi, I'm going to go up. There's 1 pi, there's 2 pi, there's 2.5. Oh, 2.75 is going to drop right in here. Okay, so again, that's 11 pi over 4, or it's like 2.75 pi. Well, now if I'm looking for a reference angle, it's going to be between the x-axis and the terminal side. Well, how much is that right there? That's actually 3 pi. If I kept going around, it's not 1 pi anymore, it's now 3 pi. So to find the reference angle, I've got to take 3 pi minus 11 pi over 4. Well, it turns out 3 pi is just 12 pi over 4. 12 pi over 4 minus 11 pi over 4 gives me 1 pi over 4. Okay, that's great. Pi over 4. Well, what is that? Well, pi over 4 is actually equal to 45 degrees. Pi over 4 is equal to 45 degrees. So I'm going to draw my right triangle in here. Which one am I using? I'm using the 45. 45, 90. The sides of those are 1, 1, and the square root of 2. Well, what am I looking for here? I'm looking for the cosine of 45. Cosine is opposite, adjacent, and hypotenuse. Cosine is adjacent over hypotenuse, so the cosine of my reference angle, pi over 4, is adjacent 1 over the square root of 2. Again, I can't have square roots in the bottom, so I need to get rid of it. Multiply the top and bottom by the square root of 2. I get the square root of 2 over 2. So that means the cosine of 11 pi over 4 is the square root of 2 over 2. Now, is it positive? Is it negative? Let's see. All students. So students, quadrant 2, sine is positive. Oh, I'm looking for cosine. That makes it negative. So my answer is 11 pi over 4. The cosine of 11 pi over 4 equals negative square root of 2 over 2. All right, we can do radians, we can do degrees, it doesn't matter. Bring them all on. Let's try another one here. Evaluate the tangent of negative 4 pi over 3. Oh boy, here we go. Negative 4 pi over 3. All right, what is negative 4 pi over 3? Well, that's like negative 1.33 pi, I believe. So let's go ahead and graph that. Going negative, so I'm going down. Negative 1, not quite negative 1.5, so it's going to stop right in there. That's negative 4 pi over 3. All right, well, where's my reference angle? It's right here. What was this? This was just negative pi. So to find my reference angle, I take negative pi minus a minus, or really plus, negative or plus 4/3 pi. All right, to figure that out, plus